Okay, so in Objective 8 we looked at writing equations for our trig graphs, and so we're going the reverse direction of what we've been doing for the last several objectives. The nice thing though is that if you know how to graph each of these functions, writing the equation just means identifying all of the attributes that you use to graph and then plugging them into their appropriate spot. So we have written at the top here, or I should say illustrated at the top here, the 6 different trig functions we've been looking at. We have our sine function, which just is a reminder, in its descriptive form, its equation looks like this. Your A for all of these is your amplitude, and this is what the sine function would initially look like. If that was flipped upside down, that would tell me that while the amplitude would still be whatever the value is, but if it's flipped upside down, it would tell us that this coefficient is negative. You have your starting point, which for sine is your HK, located right here, and you'll plug that into its appropriate spot, and then B, which is used in your period. A reminder that period is one iteration of your graph, and for sine, its period is 2 pi over B. And then cosine, cosecant, and secant are all very similar to sine. Obviously their shape looks different, but one difference between sine and cosine besides the shape is that your HK is not located at your starting point for cosine. Remember when we plotted our initial point for cosine, we still identified our H the way we do for sine, but the K value of your starting point was altered a little bit for cosine, and so you'll see that when we get into writing our equations. So reminder for cosine, and then therefore secant, since secant is just the flipped version of cosine. And then cosecant and secant are, as a reminder, just sine and cosine flipped, or I should say cut in half and flipped upside down. So if you notice here in the dotted version, we still see our sine graph, the dotted version here, our cosine graph corresponding to cosecant and secant. The one word of warning I will issue about both of these is a reminder: the 2 legs of cosecant, or I should say the different branches of cosecant and secant, they meet up at the midline. It's tempting if you were to take a cosecant graph and redraw it as sine, so you're flipping it back upside down again. It's tempting to make this U go all the way down to negative A, but a reminder that it didn't come from all the way down here at negative A, it came from your midline. And so if you are going to take cosecant or secant and try to redraw them as their sine and cosine graphs, which is a good idea, but make sure you take I should say a strong notice of what your midline is, to make sure that when you flip those U's back upside down again, you make sure they stop in the midline and don't go beyond it. Right? And then tangent and cotangent, our last 2 graphs, are shown here at the end. They have quite a few things that are different about them. So tangent, its HK, as a reminder, is the middle point. Cotangent, its HK, is on the left-hand asymptote when you're pulling out your HK. Both tangent and cotangent have asymptotes, and so a reminder of what their equations are. Tangent and cotangent have half the period that sine, cosine, cosecant, and secant do, so where these all have a period of 2 pi over b, tangent and cotangent only have a period of pi over b, so we'll want to take that into consideration. And then the unique thing about tangent and cotangent, which you will see when we get into their graphs, is that if you're just given the graph, we don't actually know whether we are looking at tangent or cotangent. Same is technically true for sine and cosine, although the graph that we look at usually is a little bit more indicative of the trig function. But tangent and cotangent, if you're just given a branch that looks like this, well, I don't actually know if that's tangent or if that's negative cotangent. Same thing for cotangent. If I'm just given a branch that looks like this, I don't actually know if that's cotangent or negative tangent. And so we will practice writing it both ways. And then obviously within homework or tests or that kind of thing, you'd want to pay attention to directions. If they specified what to write the equation as, then you would need to write it in that form. If they don't, then technically speaking, you could get away with writing either one. Okay? Okay, so getting into practicing this, we have number 1 here. As always, my recommendation is if you are watching this video for a review, I would pause the video pretty quickly and try the problems on your own. That way you can watch the video if you find yourself in need of an explanation. But if you don't need the explanation, you can fast forward to the answer. If you're watching this video for notes, I would recommend watching one, maybe two, like all the way through to get kind of a feel for what's going on. But then make sure you're monitoring that you should be pausing the video eventually and trying it on your own, just to kind of figure out what is it that you're understanding, what is it that you need to come in and get more help on, ask questions, that kind of thing. Okay? Okay, so for number 1 here, we have some steps off to the side written that are just kind of some guiding steps more than anything else. It doesn't actually matter what order you go in for these steps, because the goal for writing your equation is to find all of those missing pieces that are in your equation. What is my A for my amplitude? What is my B from my period? And what is my starting point? Remember, the starting point varies based off of what function you've identified that you are writing. And so number 1 here, that would be the first thing you'd want to figure out. What type of function are we looking at in number 1? Is this a sine, cosine, secant, cosecant, tangent, or cotangent? Okay, and so hopefully you thought either sine or cosine. Now I'll say this one looks in its full form initially most like sine. However, you could write it as a cosine graph. If you were to extend this graph one way or another, it would turn it into a cosine graph. So say I kept this going a little bit further, it would turn it into a cosine graph, but then you'd need to make sure that you reached this maximum point here at an appropriate x location. So my recommendation would be to leave it as a sine graph, because that's kind of the form it's already in. You don't have to worry about accidentally extending it incorrectly. Okay, so we are looking at a sine graph, so y minus k equals a sine b times x minus h. My descriptive form there. And so then each of your pieces, you would want to find each of them. So I myself tend to start with actually my amplitude. I know that I put finding your hk first, but for me, I usually find my amplitude first, and so that means you do want to take note of what your midline is, because that will help you with identifying amplitude. So midline, remember, is what cuts that graph in half, top, bottom. Some people like to think of it as max minus min divided by 2. That is technically what is happening. So 5 minus negative 5 divided by 2 helps you find your midline there. But this one's pretty easy just to see. So we're cut in half there at 0. And so my amplitude in this case is 5, right? Because that's the distance from my midline to my top or bottom, my max or min. So it is 5. The only other thing you'd want to consider is this then a negative 5 or a positive 5? And so depending on which way your sine graph is oriented. In this case, my sine graph should look like that. It looks like this. And so this is going to be negative 5. The only way to make it a positive 5 would be to ignore this piece of the branch and to start here at this coordinate point and extend it the other way, and then you'd have a positive. However, that will change your HK. It generates a different equation. Okay? But you can if you'd like. Okay, next up, I always actually find my period next. So period for sine graph is 2 pi over b. Same with cosine, secant, and cosecant. Tangent and cotangent are pi over b. And remember, your period is the distance across your function. And so from pi over 4 to 5 pi over 4, how far is that distance? And that distance is 4 pi over 4, or pi, whichever way it is that you prefer to write it. I'm going to go ahead and write 4 pi over 4. And then you need to figure out, okay, well, what does b need to be to make that equal, right? That is my period, so what would b be? And so if you can look at this and know what b is, great. Some people can. They'll look at it and go, oh, yeah, it's 2, of course. But if you are ever in a situation where you're looking at it going, I'm just not sure, then you can do potentially like cross multiplication if you wanted. So 4 pi b equals 8 pi, and then divide the 4 pi over, and you get b equals 2. And then I always find my HK last only because of honestly, when it's a cosecant, when it's a cosine or a secant graph where we have that shifted k element. So I always like finding my hk at the end. Nice thing about sine, hk is your starting point. In this case, my starting point is pi over 4, 0. And so I put in pi over 4, 0. And I've got my equation. Okay. Okay, number 2. Again, maybe watch one more or 2 more, whatever the case may be. Although I will say I did modify, just for the record, number 4 to be in radians rather than degrees. So if you are going to work ahead, let's go ahead right now and change that to 2 pi over 3 and 4 pi over 3 for those who are going to, like I said, work ahead. Okay, so again, watch maybe one more if you need to, but at some point pause the video, try them on your own, get that feel for what you are understanding or what pieces of this are still a little bit confusing for you that you need to either email me or come in and ask questions on, whichever one you prefer. Okay? Okay, so number 2, first figuring out what function does it look like I'm looking at. In this case, this is a cosine graph. Obviously also could be a sine graph if you were to extend it, but in its form currently depicted, this is a cosine graph, so we're going to leave it that way for now. Okay, so our y minus our k equals amplitude times cosine of b times x minus h. And so then finding each of your pieces, amplitude first for me. So finding your midline. In this particular one, we go from 8 to -4, so my midline is going to be right in here. And the question is, well, what is that value at? Middle between -4 and 8 is 2. And so my amplitude in this case is 6. Question is that a negative cosine or a positive cosine? Okay, that one's a positive cosine, so we're going to leave it as 6. If that were turned upside down, it would be -6. Okay, period. Again, cosine, sine, cosecant, secant are all 2 pi over b. So what's your period in this one? Okay, from 5 pi over 4 to pi over 4 is again a distance of 4 pi over 4. So then what would your b be? If we cross multiplied, we'd have 4 pi b equals 8 pi. Dividing the 4 pi, you'd get b equals 2. And then your hk, so reminder you have a shifted hk. So in class, some people liked thinking of their hk being this point here, pi over 4, 2. If you wanted to do it more like how we typically graph these ones, your h would still be your pi over 4, but my k again would be something different, because remember when we plug in our pi over 4 here, we get cosine of 0, which is 1, times 6, which is 6, which does not put me up here at pi over 4, 8. That would put me at pi over 4, 6. And so what do I need to get, or do to get it up to pi over 4, 8? I would need to add 2. And so you can either put plus 2 back here, or minus 2 up front here, whichever one you prefer. And actually for me, I'm going to go ahead and put plus 2 back here. So that now when I plug in my pi over 4 starting h, I get cosine of 0, which is 1 times 6 plus 2, which is 8 up here. Remember, cosine and secant are the only one that have that kind of shifted hk. Okay? Okay, again, pause the video at some point, try them on your own. Number 3. Okay, what type of function are we looking at in number 3? Okay, this one's a secant function. A times b, secant b of x minus h. Okay, so amplitude. So we do need to see our amplitude here. If you are wanting to sketch your cosine graph, you can. A reminder though, make sure that that cosine graph doesn't go too far down. So my midline for this one is here at -1. So if you want to see your cosine graph, you can, but make sure it doesn't go any further than -1. Okay, so there's my cosine graph if you'd like to see it depicted. Okay, but your amplitude, midline's at -1, -1 to 1, or -1 to -3 is an amplitude of 2. Is this secant graph upside down? Nope, that's a normal cosine graph, so this is a normal secant graph, so we're going to leave it as 2. What's my period? So 2 pi over b for secant. Take a look, -π/6 to 5π/6. Okay, it's a distance of 6 pi over 6. Solving this, what would your b be? Cross multiplying, we'd get 6 pi b equals 12 pi. Dividing the 6 pi over, you get b equals 2. I promise they are not all going to be b equals 2. The first several were, but it will change here very soon. Okay, and so then starting point, so again, this is a cosine graph. It's an inverted cosine graph for secant, but it is a cosine graph. So my starting point is initially at -π/6. But remember, I can't just put 1 into my y spot, because if I plug -π/6 in here, what I get is the secant of 0, or 1, times 2, which is 2. Okay, and I need this to be at 1, and so what do I need to do to my 2 to get it to be at 1? I need to subtract 1. And there's my secant graph. Now when I plug in my -π/6, I get my starting point of -π/6, 1. Okay, number 4. What kind of function are we looking at here? Okay, this one's a cosecant. So we have our y minus our k equals a times cosecant of b times x minus my h. Midline, where's your midline? Okay, my midline in this one is here, which is at -3. That's important for 2 reasons. One, it shows you your amplitude. What's your amplitude in this one? 3 in this particular case. But the other reason it is important is if you are going to flip this upside down to see the sine graph, again, make sure that that branch doesn't go any further past your midline here. When I flip this upside down, this u does not go all the way down to -6. It stops here at -3. Because that's what turns our sine graph into a cosecant. Okay? Okay, and so the question is, does this need to be a -3? Is that cosecant graph upside down? No, that's a normal sine graph, so we're going to leave it as 3. Okay, period, again, 2 pi over b for sine, cosine, secant, and cosecant. Cotangent and tangent are pi over b. So what's your period in this one? Okay, our period in this one from 0 to 8 pi over 3 is 8 pi over 3. And so what does b equal? Okay, we'll cross multiplying. We get 8 pi b equals 6 pi. Dividing the 8 pi over, you get b equals 3/4. And then starting point, nice thing about sine graphs is your starting point here, -3, 0, is your hk, and so my h here is going to be, I should say 0, -3. My h is going to be 0, my k is going to be -3. Got my cosecant equation. Okay, 2 more, numbers 5 and 6, we get our first tangent-cotangent combo here. And I do say combo because notice we gave no instructions, so you technically could write it as either a tangent or a cotangent graph. We will write it as both. Okay, so let's go ahead and start with our tangent. Y minus my k equals a times tangent of b, x minus h. Okay, so amplitude. Go ahead and take a moment. What's the amplitude of this tangent graph? Oh, by the way, this is a slight misprint. That dot should be in line with the 4. Okay, and so we should say our amplitude in this case is 4. Is this a negative 4? Is that tangent flipped? The answer is no, so we're leaving it as 4. Okay, period. Remember, tangent and cotangent both have a period of pi over b, not 2 pi over b. So what's your period in this one? Okay, 0 to pi, our period is pi. So what does b equal? I'd say most people can see it on this one, but if you would like to do a little cross multiplication there, just to double check, that's not a bad idea. B pi equals pi. Dividing the pi over, you get b equals 1. And then hk, where is tangents hk again? Okay, tangents hk is right in the middle. What is that coordinate point? And that coordinate point is half of pi, so pi over 2, 0. So we have pi over 2, 0. Okay, so that'd be the tangent equation. Okay, let's do the cotangent one next. Y minus my k equals a cotangent b times x minus my h. Nice thing about cotangent versus tangent, a lot of it stays the same. Your amplitude is always the same. It's just the negative or positive that changes. Your period will always be the same, but the hk will change. So our period we know is still going to be 1. Amplitude is still going to be 4, but is this how cotangent looks? We should say no. Cotangent is a graph that looks like this. It's the negative looking version of tangent, and so this would be negative 4. Okay, so the biggest thing that changes again is the hk. Where is cotangent's hk again? Okay, cotangent's hk is on the left asymptote in line with your middle point. So in this case, my hk is 0, 0. And we've got our cotangent graph. Okay. Okay, one more. Again, if you have not already, pause the video, try it on your own, restart it when you are ready to check your answers. We're doing both tangent and cotangent. Okay, first up, tangent y minus my k equals a times tangent of b times x minus my h. Okay, so amplitude, what's my amplitude in this one? Okay, well, my amplitude in this case is 1. Is this going to be a positive or a negative tangent graph? Okay, in this case, this is a negative tangent graph because the tangent graph goes the other way. Period. Tangent, cotangent have a period of pi over b. So what would my period be for this one? Negative 2 to 2, my period is 4. And so what would b equal? Okay, we'll cross multiplying, we get 4b equals pi. So dividing the 4, you get b equals pi over 4. Okay, and then where's tangent's hk again? Okay, tangent's hk is its middle point, which is at 0, 0. Okay, cotangent up next. Y minus k equals a times cotangent of b of x minus h. Okay. Well, amplitude for cotangent, same amplitude as tangent, 1. The only thing that might change, or does change, I should say, is the sign, because while this tangent is a negative tangent, it's a positive cotangent, and so we're going to leave it as 1. Period's always the same between both tangent and cotangent, so we're good to go on period. Biggest change, what's my hk for cotangent? Okay, your hk is on your left asymptote, aligned with your middle point, so my hk in this case is at negative 2, 0. So we have negative 2, 0. Okay, and that's writing equations.